Hey coders, and welcome to episode 1 of our Pandas playlist. In this episode, we're going to start pretty light in learning pandas, just learning about some of the more foundational, say, data types, such as series and data frames, as well as covering some of the basic methods in pandas. So again, in this video, we're going to learn about two of the most important data types within pandas, and they are series and data frames. And we're also going to learn how to initialize them. We're going to learn how to read in data, say from a CSV. And then we're also going to learn some of the, again, foundational, just very basic methods that you can use on data frames and series. So without any further ado, let's jump on and over to the code. Alright, we're back here in our code editor, and we are in a Jupyter Lab notebook. Again, you don't need to use a Jupyter Lab or Jupyter Notebook to run Pandas. Pandas will work perfectly fine in just a normal Python code editor like Visual Studio Code, but I think it's a lot easier to learn Pandas and to see what's going on if it's run, say, with a Jupyter Notebook. So the first thing that we're going to do is run this top cell up here, import pandas as PD. Again, whenever we import pandas, we generally give it the name PD. That's just very customary whenever you are handling pandas or using pandas in your Python file. So let's run this up here. And that is going to run. All right, so now we have imported pandas within our Python file, and we can use it with the rest of our code. So like I mentioned, there are two separate data types that are included with pandas. But if you're just using normal Python, as you know, there are different built-in data types such as lists or tuples, scalars, such as ints and strings. You have dictionaries, generators, stuff like that. However, when you import pandas, you get two more pandas-specific data types known as series and data frames. So we're going to go through each of them one by one, but just as a high-level overview, a data frame is a two-dimensional table, right? It's a two-dimensional data with rows and columns, and series are one-dimensional data, right? Okay, so let's first look at series. So as I just mentioned before, tabular data is often two-dimensional. There are multiple columns and rows in a data set, right? However, when we're just looking at a single dimension, such as a single column of that tabular data set, then pandas will convert it to a special data type known as a series, right? So again, whenever you're dealing with one-dimensional data in pandas, pandas is going to convert that into what is known as a series. It's its own special data type. So to initialize a series, we just need to pass it a one-dimensional data type basically into pd.series, and that will initialize a data series. Again, it's customary to abbreviate this as DS for data series. All right, so again, we have lots of different one-dimensional data. We have a list, that's definitely one-dimensional. We have tuple, we have a scalar, definitely one-dimensional, a string. This is a dictionary, but it can be treated as one-dimensional data because we could say that this is the dimension. This could be like an index. This is the second index, and this is the piece of data. This is the third index, and this is the piece of data. And then finally, we have a generator. So let me just actually, for simplicity, just pass in this list to prove that this data series or this pd.series initializer works. So let me run this cell. And there we go. So now we have created our very first pandas data series. So what is this output telling us right here? It looks like we have two different columns. Well, this right column right here is the actual data in the series. As you can see right here, this looks to be matching up. And then this left column right here is actually the index of all of these data right here. So just like how a list has indexes, right? This is index 0, this is index 1, this is index 2. Series also have their own index. As you can see, this data is connotated with, or is associated with index 0, and this data is associated with index 1. So again, that's just an easy way to pick out the data based on index, just like you would in a list. We get one more piece of data down here, and this is the D type, or the data type, and that's a float 64. So basically, what's that telling? That is telling us that all of the data within this series is of type float, right? It doesn't all have to be a float, but in this scenario, all of the data is float, and it is telling us that that is the case with this data series. Cool, so there are actually a couple more cool things that you can do with series that just extend past like a list. You can actually give your own series a name. So let me do that right now, and that's going to be an optional argument called name. So let's just call this, I don't know, heights. That seems to be okay. And if I run this now, then there we go. It looks like our series has a name now. Again, you couldn't really give lists a name, but now a series has a name of heights, and this could be treated kind of like as the column title, right? One more cool thing about series that also apply to data frames, so I'll cover it again when we hit data frames, but series can have their own custom index. So when it comes to lists, you're basically bound to have just number indexes, right? You can have, this is 0 index, this is index 1, index 2. But with series, you can actually give your own index, right? So you can either pass that in as an optional argument, saying index equal, and then you could pass in another list that gives the name, or you could just create it using a dictionary. So let's try this. Let's try to create a data series using this data right here. All right, so there we go. It looks like now we have our own custom index that we can reference each of these data points, right? So we can actually say, all right, give me the data in the index row 2, and that's going to now give us this number. In a later episode, we'll show you how to actually index these data points by, or how to access these data points by index. But for now, just remember that this left side is the actual index. Cool. All right, let's move on now to data frames. So data frames work very similar to series. It has its own set of methods on this data frame object. But data frames are primarily two-dimensional. Again, series are always one-dimensional, but data frames contain 2 dimensions. They contain all the different rows of your tabular data, but then also many different columns, right? This was just one column, and that was heights. Data frames can contain many columns. So again, just like with series, we need to pass in some type of two-dimensional data if we want to initialize a brand new pd.dataframe. So up here I have a dictionary that has, you can think of this as 2 dimensions, right? Each of these keys of this dictionary is basically like a column name, or it's a field, right, of the tabular data. And then as each of the properties, there is a list of different rows, right? So let me run this just to show you what I mean. So if I run this, here we go. Now our data frame, which is abbreviated as df, again, that's very customary to abbreviate as df. Now our data frame is 2-dimensional, and as you can see, each of these keys line up with each of these column titles, and then each of the elements of the properties list match up with the respective rows, right? We have M, F, M, and then row 0's M, 1 is F, and 2 is M. So that's pretty cool. That's how to initialize a new data frame, and this is what it looks like. Cool, let's keep moving on. All right, so the next thing that we're gonna see is how to read a CSV. So generally, you won't be manually writing in, hard coding your own data into like a dictionary like that and then initializing your own data frame. This is really just for like testing purposes maybe, or to demo in a YouTube video like this one. Normally you'll be reading in data from an external source, right? So one of the most popular methods for doing that is read CSV. So to use this method, you're going to have to first call the Pandas library, right? What we imported up here, you'll say pd, and then you'll say .read CSV. Now, read CSV can definitely read in CSV from a local source, right? So if you had it locally, you could definitely just pass in the local path to that CSV like this. But if you had your CSV, say, over the internet, then you can just pass in the entire URL string just like this, right? So I have data right here. It's hosted on GitHub, and this is the raw CSV file right here. So if I just take this URL right there and pass it in like that and run this, then you can see it's going to be printing out our data frame, and there we go. We have now our data frame loaded in. It was loaded in from an external source, and all we needed to do was just pass in that URL, just like that. Cool, so read CSV is very versatile, right? I mean, sometimes it's a misnomer because when it says read CSV, but you can use this method actually to read other types of formats, right? So you can use this to read in, say, a text file that's formatted like a tabular data frame. Or you could say read in a TSV. So TSV is very similar to CSV. As you know, CSV is comma separated values. TSV is tab separated values, right? So let's try to read in this TSV. So if we take that and then now paste it in this this argument right here, as you can tell, this is a TSV, and you can also see that it looks to be that. It looks like each of these are separated by a tab. If we run this, then it's actually not going to look correct just as it is like this. And that's because Pandas is still trying to read it as a CSV, but there's no commas in our data right here, right? As we can just see, there's a bunch of tabs. So there is actually an optional argument called sep. If we say sep equals, then this stands for separator. We can pass it the tab separator, signifying to Pandas that the separator is not going to be a comma like as in CSV. That's the default. It's actually going to be a tab. And of course, you can put this as whatever you want, whatever your data is separated by. But for TSVs, it is a dash, or it is a \T. So now if we run this, then there we go. Looks like it has been formatted correctly, just as what we would expect it to be. Cool, so as you can see, again, there's a lot of different columns, and Jupyter Lab lets us scroll through all of these columns just like that. There's one more optional argument I just want to quickly cover, and that is use calls. This is something that I use a lot in my own work. So use calls is basically if you had a very large data set with tons and tons, like hundreds of columns, and you only needed, say, like one or two of those columns in that data set, then you can specify which of those columns you actually want to import, right? So let's demo that right now. If I say use calls, and I can either pass in, say, one column, or what I'm going to do is actually give a list of columns. So I'm going to say, let's just take a city for now. And then also let's take in state. These are just really easy to write in. That's why I'm taking those right now. And what's one more that's pretty good? These are all pretty long names. So let's just take... let's see, one adult, one kid living wage. I'm going to copy and paste that just so I don't have to spend time writing that all out. All right, so now if I rerun this, then there we go. See, use calls is only now importing the city, state, and one adult, one kid living wage. And a lot of times that will help with memory, especially if you have, like, again, hundreds of columns, but you're only reading in these three columns, then your Python file doesn't have to hold all of those additional columns in memory. It can just hold in the ones that you imported. Cool, so that is read CSV. Again, super duper versatile and one that you'll be using a lot. This isn't the only importing module or method that you have. You can also read, say, SQL or Parquet or anything like that. But again, this one is definitely the most popular, and we'll be reviewing some of those other ones in a later episode. Cool, so let's keep moving on now. All right, so this, let me get rid of use calls just for this next demo. All right, so there we go again, back to our normal data frame, just like that. Cool, so now this next one is something I use a lot. This is called set option. There's a lot of different options that you can set in Pandas. This is mostly just for like visual effect. So for this one, this is set option display dot max columns, and then what max columns do you want to specify? And right now it's set to 100, so that way we can see all like up to 100 columns that are displaying right here. But if we don't want to see them all just like this, then we can actually reduce this number to say how about 7. And if we rerun this, then now you can see we're only seeing 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and then this ... is the 7th one, just like that. So that way it's a little bit more clean. Maybe I can even reduce that to 6. And here we go, it's still 6, so maybe I'll reduce it to 5. There we go, 1, 2, 3, 4, 5. All right. So this is mostly used again if if you want to increase this again, or just to show how many columns you want to display. So if you load in a data frame and it's only showing you like a certain amount of columns, say like right here as the default, then you can always set this option to show like 100 columns, or whatever you want your max columns to be. It could be even like 1,000. And there we go. Now we can see all of the columns displayed out just like that. Cool, so this is just something you'll have to memorize, display.max columns for a set option. All right, let's finish out this video by quickly going through each of these now. All right, so it looks like when we imported this data frame, it had 100 rows, which is actually a very small amount. It's not too big at all, but let's say that you had a data frame or a data set that was like thousands and thousands of rows. Most of the time, you don't want to see all of the rows just displayed just like this, right? You might just want a sample of those rows, right? So let's say that we just wanted the first 5 rows of this data frame displayed. Well, one way we could do that is just to print out df.head, just like this. So if we run this, it's going to print out automatically because we are in Jupyter Lab again. And there we go. Now it looks like it is just displaying the first 5 rows. So that's just like a quick and dirty way to just get a sample of like the first couple rows in your data frame. If you want to see more than 5, you can always specify as an optional argument how many rows you want to see. So if I wanted to pass in 10, that would give me the first 10 rows. If I wanted to pass in just like, I don't know, 2, that would give me the first 2 rows. But if you don't pass anything in, that's going to give you the first 5 rows. Similarly, with df.tail, this will give you the last 5 rows. So it works just like df.head, but now it just gives you the last 5 rows. And just like df.head, you can also pass in like how many of the last rows and number of rows you want to see. So if you wanted 10, that'll give you the last 10 rows, just like that. So again, these are just good methods just to get a feel for your data when you're first inspecting it and you want to see like, all right, what are some of the 5, or the first 5 or the last 5 rows, what do those look like? Cool, so another good property this time, it's not a method, it's a property of data frames, is to get the dimensions of the data frame that you just imported, right? So I know if you just say like, if you want to print out df, it will definitely show it down here. But you can't really access this number. Like I can't really say, all right, df, all right, get rows or anything like that. So if you want to actually get those numbers in code, you could say df.shape. And when I run this, then it gives me a tuple of 2 values. The first one is the number of rows in this data frame, and the second element is the number of columns, right? So if I want to actually programmatically access that, since this is a tuple, I could just say df.shape and then access the first element, 0 index of this shape, and that will give me 100 as the number of rows. And then similarly, if I did that for the first index, that would give me the number of columns. So df.shape, again, is just a good way to see how many rows and columns are in this data frame. Cool. Next one is df.columns, and very self-explanatory. This just gives us the column names of our data frame. So this is just like basically if you want to see what columns are in my data frame. Looks like we got rank, city, state, population, and that lines up. So it looks like we're looking good. All right, the next one is df.index, and if we run that, then this is going to give us basically like the row names. So if we look up here again in our data frame, it looks like the indexes run from 0 to 99. And that is exactly what is showing right here. It says start is 0 and stop is 100, right? Not inclusive. And step is 1. However, if we did give names to our indexes, like we did all the way up here, or maybe we overrode it. Oh no, here it goes. If we did give indexes such as row 1, row 2, row 3 down in our data frame, then it would not show as range index. It would show just like this, where we had a bunch of different values as our index. So again, this is just a way to see the indexes, the name of the indexes of our data frame. All right, let's keep moving on. So the next one is dtypes, or the last one is dtypes, and this basically, if we run this, it just shows us what are the data types of each of the columns, right? So we can see that rank 2022 is of type int. If we go up here to verify, it looks like that is correct, right? We have numbers 1, 2, 3, 4, 5. And it looks like that goes all the way down to 100. All of these are ints. It looks like the same with population, 2020, 2010, density. We have some other data types such as float. So if we look here, land area square miles. If we go up here, and there we go. Look, right? See, so this is 300.5. Again, since there is a 0.5, this converts it into a float, right? It's no longer an int, it's a float because it has that 0.5. We also have object. So object doesn't technically mean like an actual object as you would think, maybe like a JavaScript object or something like that. It could mean that, but most of the time that's going to mean that it is a string, right? So as you can see, city, definitely this is a string, and pandas just, it identifies strings basically as objects. So again, if you ever see something like this where it says object, you can be quite sure, or you can be pretty sure at least, that it's going to be an actual string that they are talking about. All right, so that is it for this video. I guess there's one more thing that I maybe wanted to mention if you didn't pick up. When it comes to indexes, basically the indexes for a series are each of the actual like indexes that you would think of basically if you think of like a list, right? So if you think of this as the first element, the second element, the third element, then the indexes would be for each of those elements. However, the same concept applies in indexes for data frames. However, we're talking about the entire row this time rather than just a single number, right? A single scalar. So if you wanted to access like the 0th index or the first index, then it would give you back this entire row, right? All right, so hopefully that makes sense. If you have any questions, please post them down below. We're gonna get into much more complicated and exciting, though, methods and ways of handling pandas and exploring through pandas and using pandas in later episodes. But for now, I'm gonna call that a good video. And if you liked it, don't forget to hit the like and subscribe button. And I'll see you in the very next episode.